This video is made to help you solve section 4.4, problem number 17 in our homework assignments. The problem reads, a drug used to relieve anxiety and nervousness has a half-life of 16 hours. If a doctor prescribes one 2.6 milligram tablet every 24 hours, then what percentage of the last dosage remains in the patient's body when the next dosage is taken? In order for us to solve this problem, we're going to be using the radioactive dating formula, which is A equals A sub 0 ER times T. And we will be using this more than one time because we have several steps in this equation in order for us to find the percentage of medication left. For this formula, let's just go over what each one of these stands for, or what we're looking for. A equals the amount of material, T equals time, A sub 0 is the initial amount present, and R equals annual rate of decay. Before we find the percentage, we're going to have to find R, or the annual rate of decay, because what we're going to be looking for in the end is the percentage, or A as a percentage. Now, in order for us to find R, we have to remember our rule for half-life. And basically what that says is that half-life is the time it takes for 1 gram to decay 0.5 grams, or half the amount. So in order to find this, we know that, first of all, we know that we will end up with 0.5 or 0.5 grams. We start with 1 gram, plug in E. We're looking for R, but we do know that time, in this case, half-life time is 16 hours. So time is 16 and times R, because that's what we're looking for. Now, all we have to do is rewrite the equation using natural logarithm, which is ln 0.5 equals 16R. So now we'll have ln 0.5 equals 16R, and since we're solving for R, our next step will be to divide by 16. And if we do this, we're going to use our graphing calculator. We'll plug in ln 0.5 divided by 16, and we will come up with negative 0.043321698. I almost ran out of space. So I'm going to come over here and write it again so you can see it. 0.043321698. And that is R. Now, we can return to our original problem, and that is to find out the percentage of dosage remaining in the body when the next dosage is taken. We're going to go back to our formula. A equals A sub 0 ER times T. And we're going to plug in the next set of numbers that we know. Of course, we're solving for A this time because we need to know how much material is still left in the body according to what A is. We know that our initial amount of material, or our initial amount of medication, is 2.6 milligrams. It's up here. So we're going to write 2.6 E. We now know that R is negative 0.0433216988. And looking back into our problem, We know that the pill is taken, or the tablet is taken, every 24 hours. So that is now our time. And the only thing left to do is to plug this into the calculator. And once you do that, you will find that A is 0.912388.152. So now we know how much material is left in the body, or how much of the medication dosage is left in the body when the next dosage is taken. The only problem is this is not in a percentage. So we now have to find percentage. And this is fairly simple. We're just going to take that answer we just got, and we're going to divide it by our total dosage of the tablet, which is 2.6 milligrams. Then multiply it by 100 to get a percentage. And when you plug that into the calculator, your percentage will be 35.4% dosage left in the body at the time of next dosage. And this 35.4% is rounded to the first decimal place, because that number does come out very long. You will round it to one decimal place. So our answer for problem number 17 is 35.4%.